Welcome back to my channel, a little bit about everything. On my last video, what I did was I made a shim pack for a threading tool. My previous threading tool had to be shrunk down from 1/2 inch to 3/8 square, so I needed a shim pack to fit in my tool post holder. But I touched on feed rates and chip per tooth, and I gave you a formula, right? So I'm going to start off with the date. Today we are October 12th, and it's 10 o'clock. Okay. Yeah, the formula I gave you was this, right? Chip per tooth, and chip per tooth. Okay, so it's the number of cutters, the speed that you're going to spin your cutter at, and the chip per tooth. And that is for either a shell mill, right? It's for fly cutting. But a fly cutter can have either just one cutter, right? So then this doesn't apply anymore, number of cutters. You can still use it in your formula, but it doesn't apply anymore. Or you have multiple set of cutters. Well, in that case, that's going to change your feed rate, right? If one cutter is allowed, this is just an example, is allowed 7 thou per cutter. Okay. Well, if I have 1, 2, 3, 4, 5 cutters, this is no longer the case. I can, per revolution, I can take off 35 thousandths of an inch. Right? In an ideal world where your machine is rigid enough and the power isn't an issue, right? You're just worried about cutter wear. Okay? Speed, or your rate, which is revolutions per minute, cutting speed times 12, since this value is always given in feet per minute, right? So if I times it by 12, I get rid of my feet. So then I got inches. And the OD of that shell mill times pi. Okay? So in this instance, this cancels out, and I'm left with times 4 over diameter of shell mill. Okay, that's your speed. Your cutting speed is going to be given in charts for carbide cutters and high-speed steel cutters. And the manufacturer of the tool might have its own quantities, right? Its own data. All this to tell you, today I'm going to be working on the vertical mill, and I'm going to be making a clamp. And it sort of looks like this. It comes to a point with the slot here, and that's it. Sideways, just like this. With the this I would use for stuff that you can't put in a vise or clamp it or anything else. If you put a hole in it and you have this just to add pressure to it, you can end up by doing light cuts and machining something just as well. I saw this not too long ago, but this is what I'm doing here. So let's get on with it. You can see it. It's what I use for fly cutting. Okay. Maybe this will help. There. That's what it looks like. And by the looks of it, I have to rotate these chips around. You want to trim your spindle. Make sure you're not tilting from side to side and front to back. And you start off with one face, and when you flip it over, you know that face is parallel to this. So when you put it in here like this and clamp it down, you're not going to get this, a rocking motion. And then you do that side. Okay? But right now, I'd have it to get it somewhere. I might still be able to do it. I'm going to try it anyways. there. Run it as much as possible. And a little bit there. Zero. And take a light cut. Gonna try 10 thou. I'm going to bring you in over here where you can see what I see. Half a tenth. Half a thou. 5/10 difference. Well, that might be wrong because it's it only measures 5/10 increments and rounds off, so That's 4310, and I had 4315 on this one. And I wasn't even trying. What a fluke. So now since I've surfaced this side, the underside, and the back side of my blanks, okay, I'm gonna machine these ends with an end mill to make them make this exactly 5 inches long, okay. And if you remember from the previous, this has an angle on it, and this is 3/16 high at the tip. And after I finished cleaning up these surfaces, I ended up with 0.4735, a little under an inch, okay. I'm sure I could turn that into 64th or 32nds or whatever by a little conversion, but this is what I ended up with. So now I gotta tilt the head of the mill so I can create this angle. So my cutter would be angled like this, facing off this surface here. And the angle that I have to tilt that head to is, after doing the math, since this creates a triangle here, and I have this distance and that distance, all I have to do is subtract 3/16 from my almost ½ inch, and I get 0.286. Okay, well, this is my Y value. My X value, it's already given. It's 1 1/4 from the previous drawings. It was 3/4 and a ½ inch. 3/4 and a ½ inch. So now I got to find my angle, and since I have Y and X values, it's Y over X, and it's the inverse tangent, which will give me my angle of 13 degrees. It's really 12.88, but I don't have a sine block, a sine bar or anything like that to actually get the angles, and my mill just has approximate angles on it, so I'm going to get an approximate 13 degrees on there. So I set up my block again, and I'm just going to face off the sides. So this is what I meant. That's the post in the back, and the motor's tilted to that side with a 13-degree angle here. Okay, so I'm going to get my 13-degree angle downwards here, and I marked it I kept on machining at 13 degrees, which is not giving me the appropriate dimensions that I'm seeking. To get the appropriate dimensions, which are 3/4 from the tip to this point, it's 3/4 of an inch, and on the tip side I want 1/4 of an inch from that point to that point. Okay, so I've got to do my angle calculations all over. It's y over x. Y over x inverse tan gives me 18 degrees. So I've got to set that to 18 degrees, and I should get my proper dimensions at the tip of my clamp. So I'm going to readjust that and finish those clamps, the roughing, and then we'll be doing the hole for the clamping. Okay, so let's get to it. Since I've tilted the head, I've brought it back to what I thought was where it was before, but now I still have to what is called trim the table. I hope that's the correct term. What you do is you put a dial indicator on the spindle and you spin it from one side to the other, and they should be giving you the same reading on the readout. One side should mirror the other, and that should be the same thing all the way around. But my mill doesn't have any adjustments for in and out tilt, only from side to side, so it's useless trying to do that. The only thing that could actually, if I really wanted to zero that in 100%, would be either shim the back of the arm, or actually file slightly off the back of that and then try it again, and then until I hit 0. But then that's another way you could do it. Now that I've made the blank, there's a slot that goes in this clamp, and you use a T-nut and you clamp it down to the table of your mill or whatever you've got that you can clamp down onto, right? Might be a backing plate on the lathe, might be some kind of fixture, you know? So if I put my slot in the middle, I'm at 716 thousandths from the side, and if I center this 1 inch with a 1 inch cutter, I'm going to end up with 1.5. Okay, and that's basically what I'm going to do. Cut that slot, and then underneath there, 3/16 high, there's this other pattern, and the radiuses are done with a 1/4 end mill. I'm just going to rough it out with the 1 inch and dig into the corners with a 1/4 end mill. Okay, if the radius is a 1/4, that means it's a 1/2 inch. Is it not? 1/4 is a 1/2 inch. I think that's what it is. If the radius is a 1/2 inch, this radius is a 1/2 inch. It's all done with a 1/2 inch end mill. Okay? So that's what I'm going to do right now. Can you spot the error? How much you want to make a bet on the left side? I miscalculated by 1/4 of an inch, which is half the width of the cutter. Dope! Other than that, came out pretty good. This distance is centered. That one's okay, but that one's off by 1/4 of an inch.